Recently, Myfordboy did a series of videos on this rather lovely little wobbler or oscillating cylinder model steam engine. Now, he designed this, and these are his castings, as I've got a set of them here, and it was designed to be built entirely on the little Sieg CO mini lathe. And he came up with some quite inventive fixtures for the work to actually enable him to do all the machining, the drilling and the turning on this little tiny mini lathe. All you need is, apart from the lathe, is a few hand tools and some drill bits. So yeah, it was really impressive little engine, and I got in touch with him and said, if you're planning on making any more of those castings, I would really like a set. And he obviously had sufficient interest because they are now available. If you email him, I'll put the email address in the description, and you can talk to him about pricing and availability. But yeah, so there we go. I got a set. You can have either you can opt for either a brass or an aluminium stroke zinc flywheel. Because the rest of the engine is all brass, I opted for the aluminium zinc flywheel. It's a nice little bit of contrast. So yeah, so I'm going to attempt to make this. I'm probably not going to show much of the machining. I have a very small milling machine and obviously a much larger lathe than Myfordboy used, so I'm not going to be doing it exactly the same way that he did. And quite frankly, I'm crap at building things to plans, so this is going to be really interesting. But I might show some of it, but I'll certainly show the engine at the end, hopefully working with a bit of luck. So yeah, let's have a close look at the castings. So there you go. Basically, you've got the main engine frame mount, you have the cylinder, the crank and the flywheel. Now, whilst I could probably cast the flywheel on my own using my little beer can furnace, I don't have the ability to cast brass. So yeah, it's very useful that Myfordboy made these castings available. So right, let's get on with it. So I spent a few hours with the main engine casting and the cylinder casting on the little Sherline mill, and this has now been cleaned up accordingly, all the various different faces. I could have gone further, but I quite like this rough cast brass finish. So on the faces, I stopped short of actually doing that. As you can see, we do have a little bit of an inclusion here on this face, but I'm not too bothered about that. It does go around onto the port face, but it's only very, very slight on this side. I may fill that. I mean, the easiest thing to do would be to fill that with solder and then, then remachine it flat. But I don't think that's not going to be a problem. But that has actually come up very nicely indeed. As has I've simply done that face and the ends. So the next stage now is to move on and start drilling some holes. Well, I've had a little bit of progress with the Myfordboy Wobbler model steam engine. Now I'm kind of building this in between doing other projects, so it is taking quite some time to do. But yeah, did a load of drilling on the main engine casting, as you can see. Now, I drilled the crankshaft hole the same way Myfordboy did, well, more or less. He put his in a 3-jaw chuck in his little tiny Sieg lathe. I put this in a collet, held it in a collet, and then drilled it on the lathe. But all the rest of the drilling on here was all done on the little Sherline mill. The cylinder has been bored, and the various holes have been drilled in it. So that's ready to go. Next stage is to make the pivot pin for the cylinder. Got a little bit of steel rod to do that, so that's what we're going to do next. But yeah, it's coming along. So the little Myfordboy Wobbler engine is very close to being finished. Most of the parts are made now. I basically just got 3 quite small jobs to do. I've got to solder the steam inlet and exhaust pipes into the main engine block. One goes in the top and the other one goes in the side. I've got to make a small wooden base for it because I think that would be quite nice. And I've got to machine up the flywheel. Now Myfordboy came up with quite an ingenious method of machining the flywheel. Basically he used the 3-jaw chuck on his Sieg lathe to hold this initially so that he could face off the rear of the flywheel. Then he made a round piece of MDF up, which he glued to the back of the flywheel, and he used the MDF and he held that in the 3-jaw chuck so that he could machine the front. Absolutely brilliant idea. I'm going to try something a little bit different. I'm not entirely sure it's going to work, but we're going to give it a go. I'm going to attempt to machine the flywheel using an ER16 collet chuck, which is one of these. Now at the moment it's got a 9mm collet in it, and the idea is that this will go in there like that. Now fortunately the ER16 nut, as you can see quite clearly, is small enough to fit in the recess in the front of the flywheel. So that's the idea. I'm going to use the tailstock pressed against here to square this up. The ER16 collet chuck will be held in an ER40 collet chuck, and that way I can hopefully machine both face off the rear of the flywheel and machine the outside edge. Then I will remove it from the ER16 collet chuck and I will flip it over, because this side will now be nice and flat, and I will use the self-centering 4-jaw chuck that I've got to hold this so that I can machine the front, and then finally put it back in the ER16 collet to clean up any marks that the 4-jaw has left on here. That's the plan. Whether this will hold it firmly enough for me to do this, I don't know. The Boss, of course, has got pattern draft on it so that it's not parallel, but we're going to give it a go. Well, hopefully that gives you the idea. I've got the tailstock here, squaring that up against the collet chucks, and we'll tighten this up and then we'll give it a go. Now, ordinarily this is 1.5 inch aluminium. I'd be spinning this around between 600 and 700 RPM, but as this is a zinc aluminium alloy, I think we probably need to go a little bit slower because this is going to be harder than aluminium. So I'm going to start off around 550. We'll try it at that and we'll see how it goes. That's about right. So, come on that. Look at that. Yeah, I think that's okay. Might speed it up just a little bit. Yeah, it's producing quite a nice finish. Well, it seems to be holding, so I'll give that another light pass and then we'll move on to the outside edge. Now I'm only going to be taking light cuts on the outside edge because obviously you've got where the gate was on the casting. Now I've filed that off as close as I can to the basically the circumference of the flywheel, just so that it's not too knocky, but obviously I'm going to go gently until we've got rid of this, because that's going to be an interrupted cut. Yeah, got quite a way to go yet, but I have to say this zinc aluminium, it really machines nicely. Look, there's a mirror finish on that. That is really nice. Right, well I'll carry on with this and come back when I'm done. Yeah, this is machining superbly. I'm coming up on about the last pass, maybe 2 more, so we're nearly finished. think one more and we should be there. I've only been taking off about 4 to 6 thou per cut, so I haven't really been doing that much. I haven't been doing deep cuts or anything. Yeah, I think we're done. It really does machine well, that. It really does. So that's the part I wasn't sure about, but that's worked out okay. So I'm going to take it out of the ER16 collar chuck now and swap this out for my 4-jaw, and then we'll machine the front. Right, well, we're ready to go on the front face. Now, if you're wondering why I'm using a 4-jaw chuck rather than a 3-jaw chuck, I avoid chucks, jawed chucks, these days as much as I possibly can. Thanks to my great good friend Rob over on the Zanudo YouTube channel, I'm a complete convert to collets, and I use collets all the time when I can. Obviously there are some jobs where you just absolutely have to use a jawed chuck, but when I do use a jawed chuck, as far as I'm concerned, now I'm not a machinist, but in my opinion, humble opinion, the more jaws you've got, the better you're going to hold the work. So we got the 4-jaw here holding the little flywheel. Now I used some parallels which I put behind the flywheel to line it up so that it is concentric, and we're just going to skim off the front faces. That's all we got to do. We just got to clean up this part here, so that's what we're going to do. Okay, let's take some cuts. I think that pretty much just about did it. We've only really got to clean up this edge. I'll have to run a file around the edge to deburr it, and then we can center drill that, ready for the crankshaft.